Hi, everybody. This is Mr. Folly, and welcome to 3.2. This is one of the toughest, meanest sections in chemistry where we have to be able to think about shapes and figure out what they look like and draw them and make a two-dimensional flat piece of paper turn into a three-dimensional shape. So let's hop into that with the intro stuff first. Okay, so today we're going to talk about Lewis dot structures, shapes, and single, double, and triple bonds. Okay, so first of all, bonding makes substances more stable. Energy is released when bonds form. Energy is absorbed when bonds break. Okay, so this again, we're going back to our BARF. Break, absorbs, releasing energy, forms bonds, right? Oops. So delta H is negative when bonds form. So this is what we need to know about bonds forming. Delta H is positive when bonds break. So the other thing that we should have in there is when bonds form, excuse me, it's exothermic. And when bonds break, it's endothermic. And forming bonds is favored. Okay, so why is it favored? It makes things more stable. Okay, covalent bonds come in three flavors. Yay! We have the single bond, which is the longest, the weakest, and there's 2 electrons involved. Okay, so that's our one line. Why is it? Oops. Electron here, electron here. It's the longest since the weakest. Single is weaker than double. Oh, get in there. Double's in the middle, double's in the middle, and there's 4 electrons involved. So if I have a carbon-to-carbon single bond, or if I have a carbon-to-carbon double bond. Okay. Triple bond is the shortest and the strongest, and there's 6 electrons involved. So bond energy is Q1, Q2 over radius squared. So stronger triple bonds are shorter. So really the charges are going to be the same. Covalent ignores charges. Or it doesn't deal with charges. So that means we're focused a little more on radius. Okay. All right. So here we go. Now we've got new stuff. Structural formulas show the attachment of atoms. Structural formulas show, I just said that. CO2 is not COO. We've talked about carbon dioxide before. So we need to find out the correct arrangement. This arrangement is determined by the Lewis dot structure. Okay. To draw a correct Lewis dot structure, this is what your world will revolve around for the next 5 days. You're going to put the least frequently occurring atom in the middle, or C, right? So carbon always goes in the middle. Okay. Otherwise, you're going to put the least frequently occurring atom in the middle. Arrange other atoms around the middle atom. Put valence electrons around all the atoms, aiming the single electrons at each other. Okay, so we're talking about valence electrons. Quick recap of valence electrons. On the periodic table, now this is typically, Lewis dot structures are for nonmetals. 1, 2, 3, 4, 5, 6. For nonmetals. So really the 1 and the 2 we don't deal with, but 3, 4, 5, 6, 7, 8. So the column of the periodic table tells us how many dots to put. So notice how I'm going to put 1 dot for hydrogen, boop, 2 dots for magnesium, boop, boron, 3, boop, and you get it from there. Okay. But this is how you're going to add those dots. All right. And then once we put the dots around, we're going to connect the dots. La, 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 connect the dots, la, la. Okay. So this may form double or triple bonds, and the outer atoms must have 8, except hydrogen can have 2. Aluminum and boron often have 6 electrons as the central atom. Aluminum and boron, by the way, are in this spot right here. The central atom prefers 8, but if and only if it's on the 3rd period or below, it can have 8, 10, or 12. 10 and 12 are not preferred, but they're acceptable. Okay, so there's things we do that we don't prefer, but I'm not eating my favorite meal for lunch today, but I am going to have to eat it. Okay, you are the master of the electron, so you need to be able to pick pick one electron off of one atom and put it on another if you want to. You're able to form double and triple bonds at will. And you're able to, and the whole goal is get rid of single electrons. That means and pair them. So we can never, never, never have whoops, never, never, never have single electrons, okay? Positive ions, remember, if we've got ions, you can take away any electron you want. That would be a single one. That's what you're going to take away. Negative ions require you to add an electron, so then you're going to pair one up. So you're going to have a single, and you're going to pair it up. Charges of 2 or 3 means add or remove 2 or 3. So let's start with water, okay? So this, woof, man, you're going to watch this. It's going to go quick. Least frequently occurring atom, oxygen, okay? I'm going to put hydrogen just surrounding it on the left and on the right. It doesn't matter if I put it on top or bottom. I'm going to put my dots on there. Valence electrons. Oxygen has 6, and each hydrogen has 1. Hydrogen has 1, 1, 2, 3, 4, 5, 6. Hydrogen has 1. Remember how I said I would aim my single electrons at each other? Well, I didn't do that very well now, did I? So I'm going to erase these two. And if I have 6, come on, erase. 1, 2, 3. Oops, I thought it was back to my pen, and I'm not. And then I connect the dots. So I've got my dots here. Connect the dots. La, la, la. There you go. NH3. Nitrogen. Each hydrogen. Okay, so nitrogen goes in the middle, least frequently occurring. Give it the dots. I remember hydrogen has 1. Nitrogen has 5. 1, 2, 3, 4. Now my fifth one I'm going to put up here so it's not aiming at it. Then I'm going to connect the dots. Connect the dots. La, la, la. Connect the dots. La, la. CO2, we talked about it a minute ago. What goes in the middle? Carbon. Carbon. Oxygen. Oxygen. Oxygen, remember, has 6 column. Carbon, well, I'll do the other one. 2, 3, 4, 5, 6. Notice how I aimed my single electrons at carbon in the middle. Carbon has 4. Connect the dots. La, la, la. Okay, now looking right here, to see these two? I'm going to make that a double bond. So I'm going to pick these up and make them a double bond. Okay. Now, I'm still just connecting the dots. Notice if I was a moron, I could connect the dots here too, and that's another double bond, but ugh, is that ugly. So remember, as master of the electron, I'm going to put these two a little bit neater to each other, and I have 2 double bonds. Okay. And remember I said the outer electrons always have 8 unless they're hydrogen. Oxygen has 2, 4, 6, 8. 2, 4, 6, 8. Okay. So I'm going to erase those really quickly. And I just want to remind you that the inside one will have 8 as well. Okay. 2, 4, 6, 8. And remember, bonds will double count. What I mean by double count is it counts for carbon and counts for oxygen. Okay. CO3 negative 2. Carbon, oxygen, oxygen, oxygen. 1, 2, 3, 4, 5, 6 for oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Carbon, 1, 2, 3, 4. So I put all my dots around there. I did my valence electrons, and I sing, connect the dots, la, la, la. Connect the dots, la, la. Still connecting dots, making a double bond, la, la, la. Okay, so now carbon has 2, 4, 6, 8. But I have a single electron here and a single electron here. Now, you might think, incorrectly, you could do this and make a ring. Okay? Remember I said rings are wrong? That's not what's going to happen here. So what we're going to do is, if you remember, it's CO3 negative 2. So that negative 2 means I get to add 2. If I add 2, 1, 2. Now everybody has 8, and there's no single electrons. I added 2. My charge is negative 2. Okay. All right. Pickle 5, PCl5. P, 1, 2, 3, 4, 5, Cl5. Uh-oh, I did up, down, left, and right. I got to put it somewhere. You can put it anywhere you want to. I put it on the top right. Not really a good reason why. Just north, south, east, west kind of thing. I just put it there. I guess I'm the optimist because I'm thinking about going up and to the right all the time. But it doesn't matter. I could have put it anywhere. Now, same deal as before. I put all my dots around there, and I start to sing. Connect the dots, la, la, la. Connect the dots. Uh-oh. Okay, so this is a pair. I don't like to break up a pair, but I have to. I got a single here, so I'm going to keep connecting dots, la, 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 and I'm done. Okay. Now, do note what happens here is phosphorus has 5 bonds. P has 5 bonds, and that's 10 electrons. And that might not be okay, but I got to look at the periodic table to see that phosphorus is on row 3. So that makes it okay. Yay. All right, I'm going to skip the last one because it's getting kind of long. This sheet right here, we'll get into it a lot more, but this will show us many of the different shapes that we see. Okay, so the geometry of the electron pairs here, actually this, I should drop this right now. This is linear. This is trigonal planar. This would just be, we're going to get rid of this part right here. We used to do hybridization, and I didn't change the title up there, so don't worry about that column at all. But notice how these shapes get a little crazy. Okay, so trigonal planar, that looks like a peace sign. This is just bent. Notice how we don't talk much about what the electron pairs do. Straight line linear, trigonal planar, peace sign. Bent, this is bent. Tetrahedral, this wedge is coming out at you. See how it's fatter? I often draw it like this. See how it's a line like that? And this dashed line is fading away. Okay. So I do want you to notice this is trigonal plane, this is tetrahedral. Trigonal pyramid looks just like these two, look just the same, except for the top one is a pair. This one is a bond. Okay. And we'll get into the use of these guys more and more a little bit later. So looking at these, you will get used to these, and we'll do a lot with them on here, but this is a reference sheet. So I call this the shady shape sheet, and I call this us being done with this. To that, I will say, toodles.